Next, let's look at adding rational expressions together. So adding fractions or rational expressions or rational functions, remember that we need a common denominator. So if we're adding two fractions together, the first thing we do is establish a common denominator. So let's look at a simple example. Let's say we're adding 2/3 and 1/4. So what we need to do is establish a common denominator first. So the common denominator in this case would be 12. So how do we get 3 to be 12? We had to multiply that by 4. And remember, whatever you do to the denominator, you have to do to the numerator as well. So we get 2 times 4, which is 8. So 8/12 is just another way of saying 2/3. Same thing. So when we look at our denominator of 4, how did it become 12? By multiplying by 3. So whatever we do to the denominator, we had to do to the numerator as well. Then our last step would be combine our numerator, 8 plus 3, which is 11. And remember, your common denominator doesn't change. So our final answer in that case would be 11/12. Well, in these cases, we may need to factor and then do some comparing to decide what we need to multiply by. So your first step in these problems is going to be to factor. So our first term doesn't need to be factored, and I'm going to put this in parentheses, x plus 8. And in your second term, again, we're dealing with the difference of two squares. We have x squared minus 64, so that would factor to x plus 8 times x minus 8. So our common denominator, or least common denominator in this case, is going to be x plus 8 times x minus 8. So the way that I do these problems is I line them up vertically. So I have 5 over x plus 8 plus 4 times x plus 8 times x minus 8. The common denominator is x plus 8 times x minus 8. So now what I do is I compare. In the first term, I have 5 over x plus 8, but my common denominator is x plus 8 times x minus 8. So what is it missing? It's missing the x minus 8. So I need to multiply numerator and denominator times x minus 8. So in the numerator, I'm going to use the distributive property. So 5 times x is 5x, and 5 times negative 8 is negative 40. For the second, when I compare the current denominator, x plus 8 times x minus 8, to my LCD, they're the same. So I didn't need to make a change, so the numerator doesn't change either. So in my last step, I added like terms together. So we know that our denominator is going to remain x plus 8 times x minus 8. So I add like terms. So the only term that has an x is the 5x, so that remains the same. And then I'm going to combine negative 40 and positive 4, and that gives me a negative 36. So my final answer is 5x minus 36 over x plus 8 times x minus 8. Next problem. Again, what I want to do is line these problems up vertically. So I'm going to have 4 over x squared minus 10x plus 21 plus 5 over x squared minus 3x. So remember what you're going to do, you're going to factor. So again, for this x squared minus 10x plus 21, my leading coefficient is 1, so I can use the shortcut. So what are the factors of positive 21 that add to a negative 10? And that would be a negative 3 and a -7, because -3 plus -7 is -10, and -3 times -7 is +21. So my first term has a denominator of x minus 3 and x minus 7. My second denominator, I could remove the greatest common factor, which is x, and that gives me x times x minus 3. So in establishing the common denominator, I use every factor. So my common denominator is x, for my denominator here, x minus 3 times x minus 7. And I've already incorporated the x minus 3, so I don't repeat it. Okay, so I use the factor the most times it occurs in each denominator. So x minus 3 occurs once here and once here. The most times it occurred was one time. X minus 7 occurs one time and 0 times. The most times it occurred is 1. That's why I have 1x minus 7. X as a factor on its own occurs one time and 0 times in the first instance. So the most times it occurred was once. That's why we have 1. So I'm going to write my LCD and then determine what I had to multiply the original denominator by to get it. So when I have the 4 over x minus 3x minus 7, it was missing the x in the denominator, so I need to multiply numerator and denominator times x. In the second one, it had a denominator of x and x minus 3, but it didn't have the x minus 7, so I need to multiply numerator and denominator by the missing factor. I'm going to distribute 5 times x is 5x, and 5 times -7 is -35. My last step is to combine like terms. So I have 4x and 5x, which is 9x, minus 35 over my common denominator. Next example. Remember, anytime you have a polynomial, you want to use parentheses. So I'm going to start by factoring the denominators for both. So the first one is x plus 4, and I can take out a 2, and that leaves me 2 times x minus 5. In the second term, I have x minus 2 in the numerator, and my denominator is the difference of squares. So that's going to factor to x plus 5 and x minus 5. Establish your common denominator. So remember, I use every factor the most times it occurs in a single denominator. So in this case, 2 occurs once here and 0 times there. So I do use a 2 because it did occur once. X minus 5 occurs once in the numerator and once in the denominator. So that's the most times x minus 5 occurs. And then x plus 5 occurs once in the denominator and 0 in the numerator. 0 in the first term. So the most times it occurred is one time. So you do use every factor. So now compare. So in the first term, I had 2 and x minus 5. I was missing the x plus 5. In the second term, I had the x plus 5, the x minus 5, but I didn't have the 2. So now look at what we have in the first term. We have x plus 4 times x plus 5. You have to use the FOIL method or the distributive property in order to multiply these. So I'm going to distribute. So x times x is x squared. X times positive 5 is positive 5x Positive 4 times x is positive 4x, and positive 4 times positive 5 is positive 20. In the second term, I have the 2 being distributed times x minus 2. So I multiply 2 times x and 2 times negative 2. So my last step, I write my common denominator. And now I combine like terms. So there's only one x squared term. So I'll cross this out. Now I have positive 5x, positive 4x, and positive 2x. So positive 5x, positive 4x, and positive 2x. So when I add those together, that gives me positive 11x. And then I have 20 minus 4, which is 16. So my final answer is x squared plus 11x plus 16 over 2 times x minus 5 times x plus 5. Now let's look at subtraction. So remember, the rules of addition and subtraction are the same. You need a common denominator in order to combine. What I like to do, and it makes it easier so you don't mess up the signs at the end, is I change all subtraction to adding the opposite. So for instance, if you had a subtraction problem 2 minus 5, you can change it to 2 plus a negative 5. Okay? So I'm going to use that same concept in these problems. So I have 1 over x squared minus 5x minus 36 minus 3 over x squared plus 8x plus 16. So I'm going to change this from subtraction to addition, and I change the signs in the numerator only. You can have your choice, but for these problems, we're going to change the sign in the numerator. Okay, so now we're going to follow the same process. So I'm going to factor, use the shortcut. So the factors of negative 36 that add to a negative 5 would be a negative 9 and a positive 4. And the second, I have negative 3 over x squared plus 8x plus 16. That factors to x plus 4 times x plus 4, because the factors of 16 that add to an 8 are 4 and 4. So my common denominator, I have x minus 9. Now, the first term has x plus 4, so I'm going to use x plus 4. But since the second term has 2x plus 4s, I do use 2x plus 4s. So you use x plus 4 the most times it occurs in a single denominator. So x plus 4 occurred once in the in the first one, and twice in the second one. So since it occurred twice in the second, we do use 2. So now compare. So the first term has an x minus 9 and an x plus 4, but it doesn't have a second x plus 4. So we're going to multiply by that missing factor. So in the numerator, we're going to distribute, and that's just going to give us x plus 4. In the second term, it had 2x plus 4s, but it didn't have the x minus 9. So I'm going to multiply the numerator and denominator by the missing factor, x minus 9, and distribute. So negative 3 times x is negative 3x, and negative 3 times negative 9 is positive 27. So I'm going to rewrite my denominator. And if you wanted to, you could have put x plus 4 to the second power and not list both of the factors. That's acceptable as well. So now we're going to combine like terms. So I have 1x minus 3x is negative 2x, and I have positive 4 plus 27, which is 31. Next problem, I have 5x over x squared plus 7x plus 10 minus x minus 6 over x plus 5. So again, I'm going to use my parentheses. And now I'm going to factor the denominators. So I have 5x, and the factors of positive 10 that add to a 7 are positive 5 and positive 2. Now, since I have a subtraction problem, so I have minus x minus 6 over x plus 5. So remember what I said in the previous problem. I'm going to change subtraction to adding the opposite. So both of these change signs. So this is going to be over the opposite of x plus 6 over x plus 5. So my common denominator, I have one factor of x plus 5. That's the most times it occurs in either. I'm going to use an x plus 2 because x plus 2 occurs one time, and that's the most time. I've already included the x plus 5, so my common denominator is x plus 5 times x plus 2. Now I'm going to multiply by the missing factor. So in the first term, nothing's missing, so it remains 5x. In the second term, I'm missing that factor of x plus 2 in the denominator, so I'm going to multiply both by x plus 2. So notice I have a binomial, 2 terms times 2 terms. So I have to use the distributive property or the FOIL method. So I multiply negative x times x, and that gives me negative x squared. Negative x times positive 2, that gives me negative 2x. Positive 6 times x is positive 6x. And positive 6 times positive 2 is positive 12. So again, I'm going to write my denominator, which is x plus 5, x plus 2, and combine like terms, starting with the highest degree. In other words, I'm going to start with the x squared. There's only one x squared term, and that's a negative x squared. For my x, I have positive 5x minus 2x plus 6x. So 5 minus 2 is 3, plus 6 is 9. So that gives me positive 9x plus 12. Okay, the next topic is solving equations. So when we're solving equations and we're dealing with fractions, the easiest way to deal with it is to multiply each term by the LCD in order to clear the fraction. Also, we need to be aware that there are going to be some values of x that are going to make our denominator 0. So we need to make sure that our answer isn't one of those excluded values. So that's the first thing I'm going to do in this problem. So what value of x would make my denominator 0? And in this case, it would be 0. So I'm just going to make a note that I need to make sure that my final answer isn't 0. Because if x equals 0, that would make my denominator here 0, which means it would be undefined and I'd have no solution. So the next thing I do is find the LCD. So in this case, the LCD is 9x. What is the LCD again? The LCD is the number that all of your factors divide evenly into. The L means the smallest number that they all divide into. So x, 3x, and 9 all divide into 9x evenly. So our next step is to multiply each term by the LCD. So I'm going to have 9x, I'm going to put it over 1 times 3 over x plus 9x over 1 times 1 over 3x equals 9x over 1 times 5/9. You can multiply and reduce. I reduce before I multiply. So in the first group here, the x's reduce, and that leaves me 9 times 3, which is 27, plus. In the second group, the x and the x reduce, and 3 goes into 3 one time and into 9 3 times. So that leaves me 3 times 1, which is 3. And in the last, the 9 and 9 reduce, leaving me x times 5, which is 5x. So 27 plus 3 is 30. And I divide both sides by 5. So x would equal 6. I compare it to my excluded value. Since it isn't my excluded value, then x equals 6 is the solution. You could also check by plugging 6 into the original equation for x. My next example, same thing. My excluded value has to be 0. Why? Because if I plugged in 0 for x at either one of the two denominators that has a denominator other than 1, it would make it 0. So x cannot equal 0. So what do I do next? I find my LCD. So my LCD in this case would be 10x. So I multiply each term by 10x. So I take 10x times 9 minus 10x times 3 over 10x equals 10x over 1 times 6 over x. So this gives me 90x because nothing reduces. And in the second term, the 10x and 10x reduce. That leaves me minus 3. And in the last, the x and the x reduce. That leaves me 10 times 6, which is 60. I'm going to add 3 to both sides. So 90x equals 63. And I'm going to divide both sides by 90. So x would equal 63 over 90, which reduces since 9 can divide into both of these. So 9 divides into 63 7 times, and 9 divides into 90 10 times. So our answer is 7/10. Compare it to the excluded value just to be sure, and so we're okay. Our next example, first thing that we need to do is identify our excluded values. So we know that x cannot equal 0, because if our x were 0, our 4x would become 0 and our x would become 0. And x cannot equal negative 12 either, because if we plugged a negative 12 in for x for our last term, negative 12 plus 12 would be 0, which is unacceptable. So we have 2 excluded values in this problem. So the next thing we do is find our LCD. So our LCD for this problem would be 4x times x plus 12. So we take our 4x times x plus 12 and multiply it times our 1 over 4x minus, we take our LCD and we multiply it times our second term. And then we take our LCD times our last term. So in the first term, the 4x reduces. That leaves me 1 times x plus 12, which is simply x plus 12. In the second term, the x reduces. Now, look at what I have in the numerator. I have a minus 4 here and a positive 3 here. So when I multiply those together, that gives me minus 12, and I still have my x plus 12. Equals, and here the x plus 12 and x plus 12 reduces, and I have 4x times negative 11, which is negative 44x. So next, I want to distribute, and I have x plus 12, and I'm going to distribute this negative 12 times each term. And then I'm going to combine like terms. So I have 1x minus 12x, which is negative 11x. And I have positive 12 minus 144, which is negative 132. Now, I have two choices. The best choice is to move the x's on the right-hand side so I can do it in less steps. So I'm going to add 11x to both sides. And this gives me negative 132 equals negative 33x. So my last step is to divide both sides by negative 33. So x would equal positive 4 because I'm dividing a negative by a negative. So again, I look at my excluded values, 0 and negative 12, and my answer was 4, so I should be okay. My next example, I have 3 over x squared plus x plus 7 over x equals 5 over x plus 1. So the first thing I want to do is I want to factor. So this becomes 3. When I remove the greatest common factor x, that leaves me x times x plus 1 plus 7 over x equals 5 over x plus 1. So my excluded values, x cannot equal 0, or it would make the x's 0, nor can x equal negative 1, because if I plugged a negative 1 in for x, it would make the denominator 0 there. My LCD is x times x plus 1. So I'm going to take each term and multiply it by my LCD. So I have x times x plus 1 multiplied times 3 over x times x plus 1 plus x over x plus 1, x times x plus 1 over 1 times 7 over x equals x times x plus 1 times 5 over x plus 1. In the first term, x and x plus 1, x times x plus 1 reduce, just leaving me with 3. In the second, the x is reduced, and I'm going to multiply the 7 times x plus 1, which gives me 7x plus 7. And then my last, the x plus 1's reduce, leaving me with just 5x. Next, combine like terms. So I have 3 plus 7 is 10, so I'd have 7x plus 10 equaling 5x. Then I'm going to subtract 7x from both sides. So 10 would equal negative 2x. Divide both sides by negative 2. So negative 5 would equal x. Again, compare to your excluded values. And again, you can check this problem by substituting negative 5 into x in the original problems as well. Okay, the last of this type, again, the first thing that we're going to do is factor. So 10 over, this is the difference of two squares. So this would factor to z plus 5 times z minus 5. And the other, you have z squared minus 5z. You can take out a z, and that would leave you z minus 5. So excluded values, x cannot equal, or z in this case, excuse me, cannot equal negative 5 or positive 5 or 0. It can't equal negative 5 because negative 5 plus 5 is 0. Can't equal positive 5 because 5 minus 5 is 0. Can't equal 0 because if I substitute a 0 in for x, z, it becomes 0 as well. So next, I find my LCD. So my LCD is z times z plus 5 times z minus 5. Remember, we use every factor the most times it occurs. So next, I'm going to multiply each term by the z plus 5, the z minus 5. So all I'm doing is setting the LCD times each term. Now reduce. So z plus 5's reduce. The z minus 5's reduce. This leaves me z times 10, which is 10z. For the second, the z and the z reduce. The z minus 5's reduce. And that leaves z plus 5 times 5. So I'm going to distribute. So that's 5z plus 25. Solving for z, so I want to isolate my z, so I'm going to subtract 5z from both sides. So this gives me 5z equals 25. And then I'm going to divide both sides by 5, so z would equal 5. Okay, so now I have my answer. I need to compare it to my excluded values. Since 5 is one of my excluded values, it cannot be a solution. So the answer to this would be no solution. Okay, the last topic deals with solving what we call literal equations. So a lot of times you're going to be asked to manipulate formulas, maybe in your chemistry class, biology, economics, accounting, whatever the case may be. And we've done this before whenever we put an equation in slope-intercept form. So what they're going to do is give you an equation or a formula and ask you to solve for a certain variable. So in this case, we have 9x plus 8y equals 1, and we're asked to solve for x. So we want x by itself. So in this case, we're going to subtract 8y from both sides. So that would give us 9x equals 1 minus 8y. So remember, we're solving for 1x, so we're going to divide by 9. So there's two ways you can do this. I'm going to write that down the second time so I can show you both ways, because both are acceptable. So one way is to divide the whole thing by 9, and our answer would be x equals 1 minus 8y over 9. The other way is to write 9 under each of the factors, or each of the factors or terms. So here we have x equals 1/9 minus 8 over 9y. Either answer is acceptable. Another example, here we have a equals s over 3 times the quantity uppercase P plus lowercase p. It's important when you put in your answer, you put in the right case. So we're solving for capital or uppercase P. So I'm going to rewrite the formula. The easiest way to start this problem is to get rid of the fraction. So I'm going to multiply both sides by the LCD, which is 3. So this becomes 3 times capital A, and the 3's reduce, and that leaves me S times capital P plus lowercase p. And just like we normally would do if there was a number in front of parentheses, we would distribute. So this becomes S times capital P plus S times lowercase p. We're solving for capital P, so I need to isolate that. So I'm going to subtract S lowercase p from both sides. So this gives me 3a minus S lowercase p equals S uppercase P. And since I'm solving for a p, I need to divide both sides by lowercase s. So that means p would equal 3 times capital A minus lowercase s, lowercase p, over lowercase s. Remember that 3a minus sp are one factor. So I can't reduce the s's because the only thing that you can reduce 3a minus sp with is itself. Our last example, we're solving for g. So we have t equals 5g minus 5v. So again, t equals 5g plus 5v. Since we're solving for g, we want it by itself. So we're going to simply subtract 5v from both sides. So we have t minus 5v equals 5g. And again, solving for 1g, so we're going to divide both sides by 5. So this gives us g equals t minus 5v over 5. Again, because there's a subtraction symbol, separating t and v, we cannot reduce the 5 independent of the others. So our answer would be, and I'm going to use parentheses just to remind you, t minus 5v over 5.